So in this lesson 6.4, we are going to be solving polynomial equations. This lesson is actually going to spill into, well, will spill into the next two lessons as well. Um, so we're going to look at different ways to solve polynomial equations. In this lesson, we're going to look specifically at two different ways to factor. So think about how well, actually, I should say that we're also going to look at some graphing as well. But think about how we solve quadratics. Solving by graphing. This will be very similar. Um, we'll just look at where they either intersect the two halves of the graph, or where they, if you have everything on one side, then where it intersects the x-axis. For solving by factoring, you factor as far as it goes, and you set the factors equal to 0. Right? We're just going to be looking at a couple different ways about how to factor. All right, so the first part here is we are going to solve a polynomial equation by graphing. All right, so you have the equation set up where not everything is on one side, and we're going to leave it that way. What we're going to do is we're going to separately graph the left side and the right side, and then where they intersect are the values of x that are the solutions. So we're going to do that. On Desmos. So I would suggest going to Desmos. Just desmos.com/calculator gets you that graphing calculator that is good if you're going to use your TI. That's fine. You can follow along that way. All right. So x cubed plus 3x squared. Again, we're going to graph each half of the equation as a separate graph, if that makes sense. So x cubed plus 3x squared will be the first one. You can see that curve there. The other side is x plus 3. It'll be a line. Where they intersect are the solutions. And we're just interested in the x values here. So -3, -1, and 1. So the solution is -3, -1, and 1. All right. We'll do the same thing here with part B. So x cubed minus 19x minus 2 is equal to -2x squared plus 20. So again, I wouldn't even worry about manipulating the equation. Just graph both parts, and where they intersect is the solution. So it's x cubed minus 19x. Let's do that here. And then the other side is -2x squared. Plus 20. As you can see here, there's I need to expand my view, right? So we're gonna have to zoom out a little bit here. See really where they are intersecting. And it looks like right here. It looks like right here. Looks like right here. So your solutions are -5, -1, and 4. And it's as simple as that. Just where where the two sides intersect. So I'm going to leave that third one for you to try, and see if you can come up with the answer yourself. And then in a breakout room, if you want to go over it, we can go over it together. But if you're confident, then you're good too. So let's look at the next example. All right, so I did tell you in the beginning when we're going over the objective, we're going to look at some graphing. That part was pretty simple. Now we're going to look at two different ways to factor polynomials that have a degree over 2, so 3 and up, right? So one of the ways that we factored quadratics was when there was a difference of squares, right? It only worked for subtraction. We're going to look at sums and differences of cubes. So that's the formula. That probably looks a little more daunting than it really is. I'll show you how to work through it, but important to note here that a sum of cubes also works. And the formulas are very similar. So if you have a cube plus a cube, it factors into a binomial, a linear binomial, and a quadratic trinomial. If a cubed is the cube number, a is its cube root. And if b cubed is the cube number, b is its cube root. And then a squared would just be the cube root squared. ab is the two multiplied together, and then b squared is the cube root of b squared. So, and if you look at for a difference of cubes, it is the exact same terms. It's just that there's minus here instead of plus, and there's plus here instead of minus. So how do we apply this? First, note that this is a difference of cubes, right? X cubed is a cube, 8 is a cube. So we're going to use the difference formula. So this is a cubed, and this is b cubed. If we need to figure out what a and b are, again, if x cubed is a cube number, its cube root is a. So the cube root of x cubed. So that means a in this formula is equal to x. So everywhere there's an a, we're going to substitute it with an x. For our purposes, b is 8. The fact that it's a subtraction here is worked out in the formula. So you don't need to think about the 8 as negative 8. You can just think of it as 8. The cube root of 8 is equal to 2. So that means b in this formula is 2. So everywhere there's a b in the formula, we're going to substitute in a 2. So that's it. X goes in for a, and 2 goes in for b. And again, the formula has the negative, which is, since it was minus 8, that's how that's getting factored in. Now, a squared, if a is x, then a squared is x squared. Plus ab, just multiply these together, x times 2. We're going to rearrange it so it's 2x if you were to write x2, but same thing. And then b squared is 2 squared. 2 is b, so b squared would be 4. And that's it. All right. You cannot factor. If you use this formula properly with a sum or difference of cubes, you cannot factor further. This trinomial looks like it could be factorable, but it is not. There's no pair of numbers that multiplies to 4 and adds to 2. It doesn't exist. And it won't exist for any combination that you get. We're going to do the same thing with part B. It's just going to be the sum of cubes formula. So I'm going to write out the formula above it. So a cubed plus b cubed is equal to a plus b times a squared minus b plus b squared. Notice how this is the same formula that we just worked with in part A. It's just that the plus is here and there's a minus here. So one way to remember it is if it's a sum of cubes, whatever the sign is in what you started with is the first sign in the binomial. And then the first sign in the trinomial will always be the opposite, right? So if this was a cubed minus b cubed, it'd be minus here and plus here. Since this is plus, it's plus here and minus here. So in this case, again, let's figure out what is a. A is going to equal x. So it's getting weird there. A is going to equal x because the cube root of x cubed is x. B is going to be the cube root of 125. The cube root of 125 is 5. So a is x, so x plus b is 5. A squared is x squared. AB, so minus AB is going to be 5x. And then b squared is 5 squared, so 25. All right, and then that's it. Make sure the next one wasn't on the bottom of that slide. I always forget. All right, same thing here. One difference is you have that 8 in front of the x cubed. As long as the coefficient is a cube number, then this is still a difference of cubes. Or if it was plus 1, then it would be a sum of cubes. So again, I'm going to write out the formula. So a cubed minus b cubed is equal to a minus b. Now the minus is up front. And then it's a squared plus, this is now the opposite of whatever we started with, ab plus b squared. All right, when I go to factor, the cube root, so a is equal to, remember, the cube root of that first term. If there is a coefficient there, you take the cube root of it. So the cube root of 8 is 2, and the cube root of x cubed is x. And then for b, don't ever forget that 1 is a cube number. So, and the cube root of it is 1. So now when I go to do my rest of the formula, a minus b is 2x minus 1. A squared, and if a mistake is made, it's right here. Once you get the formula down, easy mistake to make is here because a squared is what's going here. A is 2x. You have to square the 2 as well. So it'd be 4x squared because you're squaring the 2 and the x. An easy mistake to make would be to not square the 2 and leave it as 2x squared. All right. AB is 2x times 1, so 2x. And then b squared, if b is 1, b squared is also. And that would be your answer there. Example 3, now we're actually going to use this to solve. So we're going to use the formula that we just talked about. And we're going to solve for x. And it's saying find all roots. And I'll point that out when we get there. One thing to note, if you ever have a GCF, you should take that out first. And what you can do is just factor out an 8, which is really just dividing away an 8. You can divide away numbers. You can't divide away variables. Anyway, and you end up with x cubed. That's going to make it a little easier. So if you ever can do a GCF, do that. Now, in this case, a is going to be the cube root of x cubed, so x. And b is going to be the cube root of 1, which is 1. So now you have x cubed plus 1 is equal to, let's just write out the formula again. So it's going to be a plus b times a squared minus ab plus b squared. X is a, and b is 1. A squared is x squared. AB is x. X times 1 is just going to be x. And b squared is going to be 1. Now that you have the factors, we're going to set the factors equal to 0, just like we did last chapter. All right, so I'm just going to draw a line. We've got x plus 1 is 0. Subtract 1, you get x is equal to negative 1. That's one of the solutions. However, we need to solve x squared minus x plus 1. There's going to be 2 more solutions we get from there. On the last slide, I talked about how x squared minus x plus 1 will never be factorable. What you get in that part will never be factorable. If it's not factorable, then you have to solve it using the quadratic formula. So that's coming back. And that's why that was sitting there, right? So in this case, in order to use the quadratic formula, I like to write out my A, B, and C. This is not the same A and B as it was for using the formula for the, the sum of cubes. In this case, we're using quadratic formula. So the A value is the coefficient of the quadratic term, so 1. B is the coefficient of the linear term, so in this case it's negative, negative 1. And the C value is whatever that constant is, so in this case, I like to find B squared minus 4AC first. So B squared is negative 1 squared, ends up being 1. And then it's minus 4 times A, which is 1, times C, which is 1. Negative 1 squared is 1, and then negative 4 times 1 is negative 4. So you're going to end up with 1 minus 4, which is negative 3. So that's the number under the square root. So let's take a square root of it, and you get I root 3. The opposite of B comes out front, so the opposite of negative 1 would be positive 1, 1 plus or minus. And it's all divided by 2 times A. A is 1, so it's going to be 2. So this will be your other two solutions. It's two solutions because one of them is plus, one of them is minus. So 1 plus I root 3 over 2 and 1 minus I root 3 over 2. So those are your two solutions combined with negative 1, getting you 3 solutions. Tell you what, I will do, let's do one more together, and then I'll leave part C for you to try on your own, and you'll get a question similar to that as an exit ticket. So for 27x cubed minus 1, this is a difference of cubes. First thing I'm going to do is figure out what's my A. Cube root of 27 is 3. Cube root of x cubed is x. And then for B, cube root of 1 is 1. So here you got, the formula is going to be A minus B times A squared plus A plus B squared. A minus B is going to be 3x minus 1. A squared, 3x going in for A. Again, you got to square the 3, so you're going to get 9x plus AB, 3x times 1 is 3, and then 3x. And then B squared is 1, because 1 squared is also. All right, 3x minus 1, so that equals 0. Add 1, you get 3x is equal to 1. Divide by 3, and you get x is equal to 1. For 9x squared plus 3x plus 1, we're going to do quadratic formula because we know that it can't be further. So A is 9, B is 3, and C is 1. B squared is 3 squared minus 4 times A, which is 9, times C, which is 1. So 3 squared is 9. Then 4 times 9 is 36. 9 minus 36 is negative 27. All right, square root of that. That can get simplified. You can take a negative 9 out, and it gets to be 3i. And then the 3 stays. So it's 3i root 3. Opposite of B is negative 3. Plus or minus, that's a plus. There we go. And it's all over 2 times A, which is 18. So we can divide a 3 out of the negative 3, the 3i, and the 18, and you're going to end up with negative 1 plus or minus I root 3 over 6. All right, so your 3 solutions are x equals 1/3 and x equals negative 1 plus or minus I root 3 over 6. And again, we'll leave part C here for you to try on your own. Second part we're going to look at here is a way to factor that is like factoring a quadratic. It's just with polynomials that are higher degree. So let's pretend for a second that this is x squared plus 7x plus 6. How would you factor that? Well, we're just looking for a pair of numbers that multiplies to 6 and adds to 7, right? So that would be x plus 6 and x plus 1, because 6 plus 1 is 7 and 6 times 1 is 6. That's all we're doing. That's all we're going to do here. Except what multiplies to x to the fourth is going to be x squared. But I'm still looking for what multiplies to 6 and adds to 7, which would be plus 6 and plus 1. Ultimately, what you're looking for is, in order to factor in this way, is this double this? And is there no x here? Right? So like if this was 6 and this was 3, you could do what we just did. It would just make this 3 and this 3. If that was 10 and that was 5, it would work, right? It just needs to be double. The first term needs to be double the degree of the second term. Let's try this here. X to the fourth, we're going to put x squared and x squared. That has to match this, which it does. Just the degree. What multiplies to negative 10 and adds to negative 3, it would be negative 5 and positive 2. And that's it. Why don't you try this one real quick on your own, and then I will fill it in 1 minute. All right. So again, set up the parentheses. You got x squared. What multiplies to negative 27 and adds to negative 6, it would be minus 9 plus 3. A little bit of a trick. Notice what we have here. X squared minus 9. That is a difference of squares. So remember back to last chapter, that can get factored into two binomials, which is x plus 3 and x minus 3. So if you can, you should do that extra step. And then here, that x squared plus 3 will stay x squared plus 3. So that only happens if what you end up with is a difference of squares. Now we're going to use that method of factoring to solve. So the first thing we're going to do is subtract the 12 over, get everything on one side. So you have x to the fourth minus x squared minus 12 equals 0. That's a 0. Okay. All right, let's factor. What multiplies to negative 12 and adds to negative 1? So that would be minus 4 plus 1. I can factor further, right? Because x squared minus 4 is a difference of squares. So you end up with x plus 2 and x minus 2 from that. Then the x squared plus 1 remain the same. So now when I go and set each factor equal to 0, you have x plus 2 equals 0. Subtract 2, you get x equal to negative 2. You have x minus 2 equals 0. Add 2, and x equals 2. Then you have x squared plus 1 equals 0. It is a quadratic that you can't factor further, but since there is no linear term, the best way to solve this one is to solve by square roots. So we're going to subtract 1 to the other side. And you get x squared is equal to -1. Now you take a square root of both sides, and you get x is equal to plus or minus square root of -1. We know we don't leave negatives under the square root, and we don't leave a 1 under the square root. So ultimately, square root of -1 is I. So you end up with x is equal to plus or minus I. So those are your four solutions. -2, 2, plus or minus I. So we have two examples left. Let me do one more for you. I'll leave the third one for you to try on your own. And then, like I said, the exit ticket will include an example like that as well. So here we're going to factor first what multiplies to 18 and adds to 11. It's going to be 9 and 2. This one does not allow you to factor any further, so we can. So we're going to have to set both of those equal to 0. X 9. Subtract 9 and you get x squared is equal to -9. Take a square root of both sides and you get x is equal to minus square root of -9. -9, square root of -9 is square root of -9 is plus or minus 3i. So we got x is equal to minus 3. And then over here for x squared plus 2. Subtract 2 to both sides, you get x squared is equal to 2. Take a square root of both sides and you get x is equal to plus or minus square root of -2. Can't leave a negative under there, so the I will come out, but the 2 has to stay. So you have x is equal to plus or minus I square root 2. All right, so those are your four solutions. You got two solutions over here and two solutions over here. You got plus or minus 3i and plus or minus I root 2. Again, I'm going to leave part C for you to just try on your own, and then give the exit ticket a try, and let me know if you have questions. We will go over the exit ticket tomorrow and start the practice. Let me know if you have any other questions. Just jump in the breakout room or ask tomorrow in class.